Hi, this is a short video on my blog post on logarithms. All right, and here it is, the logarithmic harmony of percent changes and growth rates. So you can see the piano at the top. I'll talk about that in a minute. Logarithms are important for macroeconomics for several reasons. One is that they can often model how a household or firm makes choices in a particularly simple, convenient way. And the more important reason is that multiplications and powers appear all the time in macroeconomics. For some price and initial difficulty, logarithms make multiplication and powers and exponential growth look easy. All right, so let's look at it. Just get a little sense of logarithms by looking at how growth looks different when you look at it with logarithms and without logarithms. So here's without logarithms first. There you can see growth is accelerating there. But in percentage terms, the growth is staying pretty similar. And you can see that the percentage growth rates are much more nearly constant over time. In this graph, you can see how much straighter that is because you have a logarithmic scale. What is a logarithmic scale? On a logarithmic scale, every power of 10, for example, is the same distance from 1 to 10 as from 10 to 100, as from 100,000 to a million. Now, what's up with the pianos? Well, pianos are actually, if you think of the frequencies of each key, if you go, you have 12 steps in an octave, so the semitones. So if you go from, let's say you go from a white key to the black key, next one up, you've multiplied the frequency by 1.05. So interestingly enough, the position on a piano is like the logarithm of the frequency as a result. So, and the reason they ended up with these 12 steps that were each multiplying by 1.059 and so on is that made it pretty close to having a certain number of semitones be in nice ratios like 3/2 and 3/5 and so on. And of course, an octave is a doubling of the frequency. So this is more like a logarithmic scale to base 2 because every octave is going up by base 2. Now, another thing has a logarithmic scale is an old device called a slide rule. Let me try to show you what we can do on this virtual slide rule here. So suppose I want to multiply 4 times 3. So then I pull the 1 on this sliding bit, so it's even with the 4. And then I go over here to the 3. And then I kind of read this off and it's like, okay, that actually represents 10, 11, 12. So this would take a little getting used to, but let's do a simpler one of 2 times 2. So I put this 1 on by that 2, and then I look over on this sliding bit over to the 2 and I get 4. And if I go over to 3, I get 6. And if I go over to 4, I get 8. So I'm multiplying various things by sliding it over here, then here corresponds to the 2 times the thing down there. So physically I'm adding, and in terms of the numbers I'm multiplying. So the conversion of logarithms make a multiplication into addition, you can see here. Then the one other thing that happens is I think they have logarithmic scale where things are more bunched together and or more spread apart. And so if I go to the 4 here, then I see down at the bottom, there's the square root of 4, which is 2. And if I go up to 9, I see the square root of 9 is 3. Suppose I want to know what the square root of 2 is, and I see 1.41, and that's all I can get the 1.414. Anyway, that's enough of that, but it's kind of a nice physical way of doing logarithms that people used to use a lot before the days of computers. Okay, so I have this picture of Ronald Reagan just to emphasize before and after, because where I'm going now is to talk about percent changes. So I want to take the point of view that the change in the natural logarithm is the pure Platonic percent change between before and after. It's calculated as the natural logarithm of where you are afterwards minus the natural logarithm of where you are before. The ordinary notion of percent change is the earthly percent change. It's just the straight change, where you are after minus where you are before, divided by where you are before. And then in between these two concepts is the midpoint percent change that they teach in some other economics classes, where you take the change from before to after and divide by the average between before and after. So that's the midpoint percentage change. Now let's see how they compare. So one thing to know is the rule of 70, which is that a 70% Platonic percent change is approximately a doubling. Now you can see it's not exactly a doubling, but in class, we're going to treat the 70% as if it were an exact doubling, even though rather than being, in earthly percent change, an exact doubling would be 100% increase. You can see it. If you do the calculations, it's 101.4%, but we're going to approximate that as being an exact doubling. So that's one thing you can see. And of course, 140% is like 2 doublings. 2 doublings is multiplying by 4. In earthly percent change, multiplying by 4 is a 300% increase. And you can see the approximation isn't exact, but it's pretty good. And then 210% is 3 doublings, which is multiplying by 8. And well, that's, multiplying by 8 would be a 700% earthly percent change. And it's not exactly that, but that's not too bad. Now, the second thing I want you to notice, besides that rule of 70, is how close these are for small numbers. You're talking about a 5% change. Platonic, midpoint, and earthly match very closely. Even a 10% change, the earthly is only off by 0.5%. And by the time you get to a 30% change, the Platonic and midpoint are still, percent changes are still very close, but the earthly percent change is bigger. And this is what's called compounding. When you have compound interest in the bank, it does this kind of thing. You for example, if you were earned 3% interest for 10 years, that would be a Platonic percent change of 30%, but it would compound to 35% because you're earning interest on the interest along the way. And so a nice way to think of the relationship between Platonic percent changes and earthly percent changes is that earthly percent changes are compounded versions of the Platonic percent changes. And then the midpoint percent change is just mainly, you can think of that as a pretty good approximation to the Platonic percent change up to 30, even 30 or 40%, even at 50%, the midpoint is only 1% off. But by that point, you're getting a lot of compounding into the earthly percent change. Okay. Now, let's look at negative percent changes here. instead of doublings, then we're dealing with halvings. Minus 70% is cutting in half. And in earthly percent changes, cutting in half is a minus 50% change. Okay, so we're mainly going to work with this Platonic percent change, but you need to know that minus 70% is cutting in half. And then, of course, cutting in half with earthly percent change is minus 50% change, and minus 140% is cutting in half twice, which is cutting to a quarter. Of course, cutting to a quarter is like a minus 75% change, and I'll do just one more. Minus 210% is cutting in half 3 times. That's cutting to an eighth. An eighth would be 12.5%. So if it were exact, that ought to be minus 87.5%, but it's really not that far off. So that's a lot of what you need to know. I do want to talk about continuous time growth rates. So the beauty of the Platonic percent change is to get a continuous time growth rate. All you have to do is divide by time elapsed. Take the percent change in Platonic terms, and this percent delta is a notation for the Platonic percent change in this class, and divide by the time elapsed, and you get the growth rate. And you can go the other way around. So there are a lot of ways to get a doubling. Let me give you some examples. 1% for 70 years gives you a doubling. 0.5% for 140 years gives you a doubling. 2% for 35 years gives you a doubling. 7% for 10 years gives you a doubling. 10% for 7 years gives you a doubling. By the time you're 7% for 10 years or 10% for 7 years, you've got to think of the recent growth rate of Chinese GDP. They are slowing down, but they had some periods of quite ferocious growth. All right, so that's it for percentage changes. This update you don't need to worry about, so just ignore this bit down there at the bottom, and you really have, just to review some of the key concepts. One of the key concepts is the rule of 70, that a 70% change, 70% Platonic percent change, think of that as a doubling, and minus 70% Platonic percent change, think of cutting it in half. And you can go both ways there. You can either take a doubling and say, oh, that's a 70% change, a Platonic change, and divide by the length of time. Or you can take a length of time multiplied by a percent per year, and you can figure out how many doublings you get or how long it takes to double. And then for small percent changes, they're all the same, which is really, really nice. All right, that's it. Thanks for watching.